Alright, in this video we will continue exploring and practicing finding coterminal angles and reference angles, and along the way we'll be doing sketches and seeing what quadrant in which we land. We've already done the first four, and so in this video we'll do these last four examples. So if you wanted to see how I got any of the first four, go back and watch the other video. Alright, so 13 pi over 10. We're supposed to find a coterminal angle between 0 and 2 pi. However, 13 divided by 10 is 1.3. So that means, whoops, wrong button. That means this is 1.3 pi. It is already less than 2 pi. I'm just going to recopy it. Alright, it will be its own coterminal angle between 0 and 2 pi. So we will just write 13 pi over 10 in this case. Now, to figure out the rest of these, the sketch is actually what you want to do next. Alright, as we do this sketch, remember that 13 pi over 10 is 1.3 pi. Actually, that's not approximate, it's equal. So there you go, 1.3 pi. So anyway, here's my unit circle. And so there's pi right there. Alright, semicircle. So these are pi over 2. So in decimal form, let's see, in decimal form here at the top, this is 0.5 pi. Alright, it's half of a pi. Over here, this is 1 pi. Alright, if I kept going, here's another half a pi, so this would be 1.5 pi. And of course, if I went all the way around, I'd be at 2 pi. So 0.5, 1, 1.5, 2. That's what's happening. So what quadrant will the terminal side fall in? So here's the initial side. Okay, so as I rotate in the positive direction, I'm going to 1.3. So if I rotate, there's 0.5, there's 1. If I went all the way to here, that would be 1.5. That's too much. So I'm not going to go that far. I'm going to stop here in the third quadrant. Okay, so I'm just going to stop in the third quadrant somewhere. So here's my terminal side. So this is representing my 13 pi over 10. So I wonder, can I just copy it and move it? Alright, so that's my 13 pi over 10 happening. So that's a lovely sketch. Now let's use this to talk about the reference angle. My friends, understand that the reference angle is right here against the x-axis. So right there where I put the R, that's my reference angle. Notice that the reference angle falls between 13 pi over 10 and 1 pi. So if I want this angle in the middle, I need to subtract these two, bigger minus smaller. So for the reference angle, in that case, I need to do 13 pi over 10 minus pi. Alright, this minus this. So I need like denominators though. So this would be like, you know, I'm multiplying by 10 in the numerator and the denominator. So this is going to be 13 pi minus 10 pi over 10. So 13 minus 10 is 3. So that's going to give me 3 pi over 10. So that is going to be my reference angle. Okay, notice that it's not just pi over 10. It's 3 pi over 10. So that was my reference angle. Of course, we are in the third quadrant here, so this is quadrant 3. And so that's it for E. Now for F. This is negative, so clearly I need to add to get into the range, because I'm supposed to be between 0 and 2 pi. So I'm going to have to add 2 pi to this. Now, as I contemplate adding 2 pi, remember this is like 2 pi over 1, and I'm going to need like denominator. So I'm going to wind up multiplying this by 4. So you can probably see that I'm going to wind up doing 8 pi over 4. So that's what I'm going to do. So I'm going to add 8 pi over 4. Okay, so this is negative 15 pi plus 8 pi. That's going to be negative 7 pi. Okay, so that's negative 7 pi over 4. Well, that's still negative. So I'm going to have to add another 8 pi over 4. Okay, so let's do it again. Another 8 pi over 4. Got to get into the positive zone. Now I'm going to get what I need to get. Can I move this over? Negative 7 plus 8 is 1, so that's going to give me pi over 4. So this is my coterminal angle right there. Alright, next let's do the sketch so we can see what else we need. So negative 15 pi over 4. So here's my unit circle. Alright, here's pi in the top, and I'll split it up, and then that makes pi over 2. Okay, so if I split it up further, then I'll have pi over 4. Alright, so each one of these portions is now pi over 4. Now I need to go negative 15 pi over 4 to graph this. Alright, so here is standard position, starts off right here. Because I'm going negative, I'm going to go clockwise like this. Now remember, I've got 8 pi over 4 in the entire thing. 4 and then 4. I've got a total of 8. So if I go all the way around, okay, that's 1, 2, 3, 4, 5, 6, 7, 8. So I've gone 8 pi over 4 so far. If I went around again, oh, I should say negative 8 because I'm going this way. Okay, so that's negative 8 pi over 4 so far. If I go around again, alright, let's say if I went all the way around again to here. So that was negative 8 and then negative 16. So that's 1 too many. Alright, so I needed to stop short. So instead of going all the way around again and back to here, because that would be 8 and then 16, I'm going to stop short at 15. So if I come back around and I'll stop here. So if I had gone all the way, that would have been negative 16 pi over 4. But I'll stop one less. And of course I could sit here and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 until I land here. But I'm trying to show you how you can speed up the process. So here's my terminal side right here. So notice the reference angle that we predicted. When you have special angles like pi over 4, pi over 6, or pi over 3, it's just going to be pi over the denominator. But here we can see it visually. There's the reference angle right here. this is in the first quadrant, as you can see. And I think that's everything that we needed for F. So let's go ahead and do G. 19 pi over 8. Let's see, 19 over 8, my friends. 19 divided by 8. So that is approximately 2.4 pi. So that's bigger than 2 pi. So I definitely need to subtract to get down, because I need to be less than 2 pi with my coterminal angle, which I'm going to put here. So we need to subtract. Now remember, as I imagine subtracting 2 pi like I want to do, remember this is like 2 pi over 1, and I'm going to wind up needing like denominators, so I'm going to multiply this by 8. So to match that. So this is going to be negative 16 pi, don't you see? So that's what I'm going to do. I'm going to subtract 16 pi because of this. 16 pi over 8. So fine. So that is going to give me, so 19 minus 16 is 3. So that's going to make 3 pi over 8. So that is my coterminal angle. So let's go ahead and do the sketch next so we can see what is what. So 19 pi over 8. Okay, I'm about to sketch that. So remember that this was approximately 2.4 pi. Alright, remembering that will help us do the sketch. So here's our unit circle. Alright, here's pi, and here's pi over 2. Okay, in decimal form, remember that up here at the top, half pi, that's like 0.5 pi. And then over here on the left, that's pi, so you know 1 pi, if you will. If I keep going around, this would be 1.5 pi. Okay, and if I kept going here, I'd be at 2 pi. Right? Now, we're going to 2.4 pi, okay? So, here was my initial side right here. So here's what happened. Alright, if I go all the way around, alright, I think we can agree that that's 2 pi so far. Now if I went another quadrant, that would be 2.5, but that would be too far because this is approximately 2.4. So I'm going to stop short of that. Alright, so I'm going to stop somewhere in this area. So it's going to be like this. Alright, and that is my 2.4 pi, which of course is 19 pi over 8. Okay, so let's drag all this over. Alright, I don't need the decimal anymore, so I'm just going to get rid of that. So, that's the sketch. Now, over here we're supposed to talk about the reference angle. The reference angle. Now, my friends, understand that the reference angle is this angle right here where I just put the R. It's always measured between the terminal side and the x-axis. Now, can you see that this reference angle is between 2 pi and 19 pi over 8? So I need to subtract these two things. Alright, so I'm going to just do 19 pi over 8 minus 2 pi. Alright, 19 pi over 8 minus 2 pi. Now I'm going to need those like denominators, right? So, you know, let's multiply it by 8 in the top and the bottom. So that's going to make this 19 pi over 8 minus 16 pi. So, you know, this is the same thing like we were doing before. And so that is going to be 3 pi over 8 like we got the last time. Okay, so that means this is the reference angle. So in this particular case, the reference angle and the coterminal angle were the same thing. But of course, that won't always happen. Alright, clearly we are in quadrant 1. So there's that. Okay, so that was it for G. So one more of these, 15 pi over 2. Alright, first we need a coterminal angle. Now 15 over 2 is 7.5. So that is more than 2 pi, but it is way more than 2 pi. So we're going to wind up subtracting 2 pi more than once. Or you could subtract some multiple of 2 pi, like 4 pi or 6 pi. Whatever's easier for you. But first of all, if I'm going to subtract 2 pi, remember I'm going to wind up needing like denominators. So I'm going to wind up doing this, so I have like denominators. So when I do the subtracting, I'm going to be doing 4 pi. So I'm going to wind up subtracting 4 pi over 2, right? Alright, so if I do that, 15 pi minus 4 pi over 2, that's going to give me 11 pi over 2. Alright, that looks weird. Let me separate that a little bit. 11 pi over 2. Now, 11 divided by 2 is still bigger than 2 pi, right? Because 11 divided by 2 is 5.5. So it's still too big. So I need to subtract 4 pi again. Okay. Now 11 minus 4 is going to be 7 pi over 2. Okay, so we're getting closer, but 7 divided by 2 is still 3.5. So that's still bigger than 2 pi. So I need to subtract another 4 pi. Okay, so that 7 minus 4 is 3. So 3 pi over 2. Alright, and that finally brings us to the actual answer of 3 pi over 2. Okay, because that is 1.5 pi, so that's finally less than 2 pi. So that's where we stop. So notice that I subtracted 4 pi 3 times. I could have subtracted 12 pi right from the start. Okay, I could have thought to myself, as soon as I saw that I was going to do 4 pi, I could have thought, how many multiples of 4 fit inside of 15? 4 pi, 8 pi, 12 pi. all of those are less than 15. So I could have just subtracted 12 pi and been done with it. So that would have been quicker. Alright, let's go ahead and do the sketch now. 15 pi over 2. Alright, so we're doing 15 pi over 2. So let's go ahead and draw this thing. It's crazy. Alright, so there's pi over 2. Alright, so here is the initial side. Now I'm supposed to do 15 pi over 2. Now each one of these sections is pi over 2. And the full circle is 4 of them. So can we agree that if I do a complete rotation, that is 4 pi over 2? Okay, because I went through 4 of them. So that's 4. If I go again, that's 8. If I go again, that's 12. Okay, 4, 8, 12. Now I'm shooting for 15. So I've got 12 so far. So that's 13, 14, 15. Okay, so that's going to put me terminal side right here. There's my sketch. Okay, so that's going to, because we are on the axis, there will be no reference angle. Alright, there's no 90-degree reference angle. So we will just put not applicable. Okay, there is no reference angle on the X or Y axis. Now in terms of what quadrant or whatever, we are on the negative Y axis. Okay, and I think that's it. I think we've done it. Alright guys, that is going to do it for this video. Alright, that is how you find, for each one of these, remember we found a coterminal angle, we found a reference angle, we did a sketch, and that let us know what the quadrant was going to be. A couple of pointers. Remember that if it's a special angle like pi over 6 or pi over 4 or pi over 3, the reference angle is just going to be pi over the denominator immediately. But if it's anything else like 11 or 10 or 8, something random, then you need to do the sketch and you need to see where the reference angle falls and subtract. Like when we did this one, the reference angle was right here against the x-axis. We had to subtract because it's between 13 pi over 10 and pi. We did 13 pi over 10 minus pi, like denominators, kabam. And last but not least, don't forget that when we talk about reference angles, if it falls on the x or y axis, there is no reference angle. Alright guys, I hope this video has been helpful for you. I will see you on the next video.